Hi, I am Anurag Singh, presenting my solution on TechSurf25. Imagine you are searching in Contentstack for red sneakers, but getting red apple. Frustrating, right? That's why I build a semantic search app that understands the meaning behind your query and give results based on their semantic meaning. Before going to my actual implementation, first let's understand how semantic search works, how it gives relevant result based on their meaning. So first of all, we have all our data in text format. Now, with the help of embedding model, we convert this text into vector, which basically mean a list of numbers that represent the meaning of the text. Now, these vectors are stored in a special type of database called vector database. Unlike traditional database, vector database is designed to handle high dimension vector and find similar one quickly. To make this retrieval efficient, vector database perform indexing. There are different indexing algorithms such as inverted file index, product quantization, and HNSW. Out of these, HNSW, which stand for Hierarchical Navigable Small World, is most widely used. Now, when user enter a query, we also generate an embedding for that query. Then, we compare that query embedding with the stored document embeddings using cosine similarity. Cosine similarity simply measure closeness between two vectors. Now, if we calculate cosine similarity of all our queries with all available embeddings, then it takes a lot of time. So HNSW make this comparison efficiently. In HNSW, it store vectors layer by layer. So layer 0 have all the vectors, layer 1 have a limited number of vectors, and as we go upward, the number of vector decreases. So instead of checking every vector, it follows the most promising path based on cosine similarity, and the time complexity of this algorithm is log n. So now we understand how semantic search works. There are three important factors which determine the quality of our search result. The first one is the quality of document. The text should be well structured and ideally summarized in about 200 to 500 words. Second, the dimension of embedding vector, which represent how many features we can capture from our text. It ranges between 500 to 3000. And the third one is the choice of embedding models. I have tried all of them, and the most accurate result I got from the Gemini embedding model 001, which is the latest model released in July 2025. So these are the features of my semantic search app. I will explain them in the later part of the video. So this is my app configuration screen and full page app inside Contentstack. I will show them in detail in the later part of the video. Now let's see the architecture of my project. First, the user install our app, then see the configuration screen. The app uses Contentstack App SDK to fetch available content in the user stack. At the same time, our server is called to check if any content types have already been sent earlier by the user. The user then select the content types for which they want semantic search and click the send button. Once syncing start, all the entries from the selected content types are sent in bulk to our server. The first step on the server is data preprocessing. It is handled by Gemini Flash 2.0. So the raw content stack JSON entries include extra field like IDs or system metadata that are not useful for embeddings, and content schema can differ across tags. So to handle this, we extract only the meaningful part from the entries and generate a descriptive summary about 200 to 600 words. This improves the quality of our embeddings. In addition, we also structure fields such as short summary, image URL, post URL tags, dates, and other metadata. So after pre-processing, we generate embeddings for the descriptive summary using Gemini embedding models and store them in a vector database, which is Pinecone, along with the metadata. So now, when user later update their entries, asset, or content schema, Contentstack triggered a webhook to our server. So for entries, we repeat the pre-processing embedding generate before updating the vector database. For asset or schema changes, we only update the metadata since these fields do not affect embeddings. Also, we have included if a user uninstall our app, then we completely remove user stacks from our vector database. Now let's discuss the tech stack of my project. For the marketplace app, I use React along with the Contentstack app SDK to fetch user entries and send to the server. On backend, I build it with Node.js and Express. For AI, I use Gemini 2.0 Flash for data cleaning and pre-processing. and Gemini embedding model 001 to generate embedding with a dimensional size of 3072. These embeddings are stored in Pinecone. And for semantic search, I apply cosine similarity to retrieve most relevant result. Finally, backend is deployed on render while semantic search marketplace app is hosted on Contentstack launch. Now let's come to working demo of my project. So this is my Contentstack account. I have two stacks. Now let directly go to Developer Hub and install our semantic search app. So on UI location, app configuration and full page, I have set up. This is my webhook setting. This is my webhook endpoint. This is the custom header to verify webhook calls, and this is my app events. Install and uninstall. This is my stack events. Any entity, create, update, delete, update, delete, update, delete. Now let's go to hosting. This is I have hosted on launch. The URL. Now let's directly install our marketplace app. This is my dummy blog website, which contain around 53 entries. These are the entries. Now let's select our stack. So this is my app configuration screen. Here user can select the content types for which he want the semantic search. So earlier I did it differently, like on webhook install call, I directly fetch all the entries and sync and store in our vector database. But I think this is the better way. Here user have the freedom to choose the content types, and also it show the timer also, so user can clearly see how much time it will take to sync all the content. This is my vector database. So I have stack level separation. So here if I fetch a result and show, so this is my namespace, this is the stack level, and this is my content type ID. This is my full text for which we generate our vector embeddings. There are other metadata also which we will show in search results. So our sync has been completed. Now let's directly open our stack. So this is the UI location of our semantic search app. So here you can filter based on content types, local and date. So let's search some queries. If I search, you can see I am getting right result on the top. It rank based on the similarity. We can load more also. So if we click on the entry, it will directly open the edit section. So here we can edit the entry. We can directly open the deployed link also if the entry is published. Now let's compare our search result with keyword matching. So here you can see we are not getting the right result in top 10. Let's search some other queries. So here also we are getting right result based on the similarity. So if we do here, so it's not giving the right result. It's just matching digital keyword and based on that giving. So if our query is very small, then also it's working. You can see in this entry, I have not directly mentioned is equal to MC square, but it is giving right result based on the similarity. In different language, we can search also. Now you can see in Hindi also I'm getting results. We can filter based on local also. So if I select Hindi, then I get all the entries which are available in Hindi. Multilingual similarity is also able to detect, like you can see we are getting right result. So now let's see filter based on date. So let's see based on the updated date, you can see I have updated this post on 17th September. Now if I select it today, so you can see I'm not getting that same result. I'm only getting the one which is updated on 19th. So here also we can open the app configuration settings. Here we can delete the content type also and sync if we want some other content type. Now we can filter based on content types also. So if I have select blog entry, then I get all the entries which are in content type blog entry. So I can select page also. Now I get all the page entries. So if I click these also, then it's directly open. Now let's see our webhook functionality. I will add a new entry and let's see it is added in our vector database or not. So when we add a new entry, a webhook call goes to our server. So our server first check if that content types is already exist in its stack. If it exists, then the entry's content is first pre-processed by Gemini. Then embedding is generated. Then it will be stored in our Pinecone database. So for update also, if we update any content in our entry section, then the same thing happen again. So whether you create a new entry or update the previous one, the same thing happen. Now let's see, will it appear in our search result or not? So you can see we got our result. Now if we try to update its title, let's make it AI agents and see. So you can see now also it's updated successfully. Now let's try to update our asset section. So you can see I am going to update the Contentstack agent OS image. This one image I am going to replace. You can see now. So when we update our image, a webhook call goes to our server and it will just update the metadata field. The pre-processing step and the embedding generation will not happen this time. So you can see I am replacing it with some other image. Now you can see it's successfully updated. Now let's see what will happen if we delete this image. Yeah, it also work. When we delete, a webhook call goes and it will clear from our metadata. Yes, you can see now this image has been deleted successfully. Now let's try to update the content type name. Now let's change from blog entry to tech blog entry. So now this is also a metadata field. So it will replace all the entries which contain blog entries and it will replace with tech blog entries. Now let's see. So you can see in filter it has been successfully updated. And when we search, you can see we are getting latest tech blog entry section. Now let's try to delete the content schema. So this is the author. These are three schema pictures. So we will going to delete the picture. Now let's first see. I have all the pictures. I will change the filter and you can see I have a filter schema in all my entries. Now if I delete it and save, now you can see from all the entries it has been deleted. But the other entries, yeah, they have the image part. Now let's see what will happen if a user delete the complete content type. So let's in my different text starter, I'm going to demonstrate. So you can see in the pages, I have these 4 pages. So if I delete it, so if it will delete all the entries from that content type. So you can see from filter it has been deleted and from if we search, then also you can see we are getting headers, blog entries, but we are not getting the page content type. So it has been successfully deleted. Now finally the last step, what will happen if the user will uninstall our app? So that also I have handled. It will completely remove the user all the content type and all the entries Basically the complete namespace we have created in our database. Now you can see we have two namespace. Basically this is the stack API stack APIs, and if we delete, it has been deleted and all the entry data has been deleted from our vector database. Now you can see we have only one namespace left.